So let's say we have two shapes, or in this case, two people, and we suspect that they are congruent. Well, we are given the fact that they have the same height, they have the same weight, and they have the same shoe size, and from the appearance, they look the same. Based on that given information, we have to ask ourselves, well, they have to have the same leg lengths in order to have the same height, or the same shoulder width if they're wearing the same shirts. Maybe we observe now that they have the same nose. I mean, if we're going to make the claim that they are both congruent, that they're identical twins and they're congruent, well, golly, they have the same smile and they have the same hairline. I mean, if they are congruent, everything about them is exactly the same. All we need to know are a few things about these two twins, and then knowing that, we're able to infer or know that everything else about them is congruent as well. This idea that knowing that two shapes are congruent and knowing that everything else about them is congruent is what CPCTC is all about. It stands for corresponding parts of congruent triangles are congruent. Now, I will refer you to previous videos about what corresponding parts means. But essentially, if I'm looking at my right hand, your corresponding part would be your right hand. So our corresponding parts would be our right hands, or our left legs would be corresponding parts. So with triangles, maybe angles might be corresponding parts, or maybe sides are corresponding parts. If we have congruent triangles, and we know that they're congruent, then everything about them is congruent. Now, how do we prove that triangles are congruent? Ooh, that was my big one. We will use SAS, SSS, ASA, or AAS to prove that triangles are congruent. And again, I will refer you to previous videos on how to do that. But here's a goodie. Once we prove that the two triangles are congruent, we pretty much say CPCTC, and we get everything else for free. So essentially, you buy 3, you get 3 free. So here are two shapes, and let's kind of talk words and not use geometry as much. Just talk words. But here we have two triangles, and we are given these two angles are congruent. This side corresponds with this side, and this side, BC, corresponds to side EC. Now you'll know that they gave us a pair of sides, and they gave us the angle that is included by those two sides. So if I have two sides and the included angle, that is SAS. But look at what we're trying to prove here. We're not trying to prove triangle congruency like we've been used to doing. We're proving that AB, so this triangle length, AB, is congruent to DE. So the idea here is if I'm going to prove with triangles a pair of sides or a pair of angles, is going to be because of CPCTC. But we cannot use CPCTC until we've used one of these 4 right here. So here's what I propose to you. We can prove that these two triangles are congruent by the SAS postulate or theorem, because I'm given the two pairs of sides and the included angle. And if I can prove it using SAS, then I can say by CPCTC that these two sides are congruent. Now, for those of you that missed the memo, I typed it up for you. Looking at our second drawing, let's see what they gave us. They gave us a pair of sides, so PR is congruent to SQ. That's a pair of sides. And they told us that PQ is congruent to SR. That's another pair of sides. I need a pair of angles or another pair of sides. Now, Hopefully by this point you recognize a certain pattern, and that's that these two triangles are sharing this side. So I can say that this side is congruent to itself because of the reflexive property. So we have SSS. So if we prove these two triangles are congruent by the SSS, then we can say CPCTC to get that angle P is congruent to angle S. So this is like my last step, right? And notice that in both cases, the last step is pretty much CPCTC, and the step right before that is I have to prove triangle congruency. Notice that. So in this first one, right, we proved triangle congruency by the SAS, and then we said CPCTC to get that what we're trying to prove. Same thing happened with the second one, right? We went ahead, we had to use reflexive property first to get our three congruencies. And then once we were able to do that, I could invoke one of the four triangle congruencies, SSS in this case. And then immediately after I said CPCTC, and you get this. So here's a full two-column proof. There was some confusion among students of what a two-column proof was. A two-column proof has two columns. The first column is statements and the second column is reasons. And if you look back at previous videos leading up to this topic, we've done many two-column proofs, and I just want to make sure that we're clear what a two-column proof was. The first column has statements, the second one has reasons, and we list these in a logical order. We're given that DB is congruent to CB. That's great. So that's already one pair of sides. We're given that AD is parallel to EC. So that's not a congruency. And we want to prove, we're not proving that the triangles are congruent. We're proving that AB is congruent to EB. That means we cannot use it in the proof until the end. So this is going to be my last statement. Because we're proving it, we can't use it. So we can't say, oh, I'm going to mark this right here and say we have these sides. We can't do that. It wasn't given. So far, all we have is a pair of sides. Well, if AD is parallel to EC, parallel means we have alternate interior angles. So I'm going to go ahead and look at angle A being congruent to angle E because alternate interior angles are congruent. Now, we should have caught this one even earlier, but this is a bow tie, and bow ties should remind you of vertical angles. That being said, I have angle, angle, and a side. This is not the included side. This is not the side between these two angles. Now, for those of you saying, Mr. Over, we could do this a different way. Yes, you can. So if you want to, you should. Okay, I would suggest write it down what I'm going to be doing, but then do the proof again, doing it an alternate way. That would be very good for you. So let's look at this proof then. We were given that DB is congruent to CB, so that's a pair of sides. Using the parallel lines, we were able to prove that angle A is congruent to angle E. That's a pair of angles. And that's because alternate interior angles are congruent. And then ABD is congruent to angle EBC because these are vertical angles. They're angles that are across from each other, and they connect, they attach at this point right here. It's like a bow tie. These are congruent to each other. They're vertical angles. That's a pair of angles. Now remember, our only options are SSS, SAS, ASA, AAS, and we don't have the letters for that, and we don't have the letters for that. So these are my two options. We have to see if the side is in between the two angles or outside of those two angles. And we note that here's the angle and here's the angle. If it were included side, it would be AB and it would be BE. But we were not given that. We were given the side outside of the two angles. So that's why it makes it AAS. It doesn't have the included side. We're not done with the proof, right? Because we want to prove that AB is congruent to EB. And as soon as we prove the triangles are congruent, like I said, the last step, the next step almost immediately is going to be CPCTC to get what we're trying to prove. For your summary, where in a proof does CPCTC come in? And if you forgot what CPCTC stands for, it stands for corresponding parts of congruent triangles are congruent. I would suggest when you do your assignments, actually say the words because it has a lot more meaning. Otherwise, you're rambling letters. So it might help to say corresponding parts of congruent triangles are congruent. Remember, that means my right arm is corresponding to your right arm. And if we happen to have congruent right arms, even better. What is CPCTC usually used to prove?